dH in the plane of the screen does not create that type of shift that we need, up or down type of shift for electrons. dV will be able to create that, which is perpendicular to the plane of the screen. If we take dV to be dot, where do you think electrons will accumulate? Lower side or the upper side?
So upwards.
Upwards. Right. So electric current is given. So we need EMF. EMF will be BV, LV. Current will be that EMF divided by the resistance, which is how much is the resistance? Well, actually, resistance of the rail is to be neglected here. Take the resistance of the rail to be 0. And that means for the whole circuit, the total resistance will be 0.2 ohm. Current is given. Speed is given. Length is given. Find out dV. Once you have found out dV, then dip can be obtained in this manner: BV, BH, B, theta. Theta equal to BV by tan theta equal to BV by BH. So do the math and see if you are getting tan theta as 1 by 3. Any questions? Let me know. So then I suppose we proceed further. Two circular loops are placed coaxially but separated by a distance. The radius may not be the same. Battery is suddenly connected to one of the loops, establishing some current in it. Let's say there is a battery here. Suddenly connected. Okay. Will there be a current induced in the other loop? What do you think?
Yes, sir. Because there is sudden change in flux.
Okay. When does the current start and when does it end?
In the second coil, as when the battery is connected, that's when the current starts. And since in the first coil, the current is attained a stable value, then there will be no change in flux. In the second coil, during that phase, there will be no current. And when the battery is removed, again there will be current in the second coil.
I don't think battery is removed in this question. So when the current becomes stable in this coil, when the current becomes stable, only till then current here will last, and then current will have some stationary value in this coil. Then there is no current here. Do the loops attract each other or do they repel? Yes. What about this? Somebody else? Yes, Bhuvan, how about you? Do they attract each other? Do they repel?
So they attract each other?
They attract each other. Let's see. Suppose as seen from here, the current is clockwise. As seen from here, suppose the current is clockwise. Then what do you think will be the direction of current here as seen from here? Yes, anybody?
It would be towards the viewer.
As seen from here, what do you mean by towards the viewer? As seen from here, it can either be anti-clockwise or clockwise. Yes?
Clockwise.
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 Let me see. If here it is clockwise as seen from here, let me do it like this. Then as seen by us from here, from the front side, current will enter from here and will come out from the top towards our side, dot. That's how the current will be, right? If it is clockwise as seen from here. Now that type of current will create magnetic field here, which will be towards the left side or right side. Left side or right side? Right side, right? Here it is dot current, here it is cross. So due to this current, field here should be to the right side, isn't it? Now, if it is in the same way, dot here and cross here, then it seems to be supporting this field. How is that possible? It should oppose. So it can't be the same way. It has to be the other way. If it is clockwise to the left, it should be anti-clockwise for the right. If it is anti-clockwise for the left, it should be clockwise for the right. So what do you think? Will it be repulsion or attraction?
So repulsion.
Repulsion. So the correct figure for right side will be There's another way to think about the same problem. Other way to think is that that current on the right side will try to oppose the flux change. So if it tries to run away by increasing the distance between them, it is basically trying to dilute the effect of flux change. When it tries to run away, it basically tries to dilute the effect of flux change. That could be another way to look at it. But this is the typical way that we look at it, the field generated. Any questions, let me know. Next, the wire AB is slid on the fixed rails with a constant velocity. If the wire AB is replaced by a semicircular wire, the magnitude of the induced current will increase, remain the same, decrease, increases or decreases depending on whether the semicircle bulges towards the resistance or away from it. Alright, So basically, if you replace this wire AB by this semicircle or this semicircle, what happens? Increase, decrease, remain the same, or it depends which type of semicircle is it, concave or convex. So what's your answer?
So it would be D.
Beta or delta?
Delta.
So beta.
Sure, beta, B.
Why should it be beta? Why?
So B.
Yes, why? We discussed some results earlier. What was that result? That staircase type of approach. This can be replaced by some semicircle, but then semicircle can be thought of as something like a staircase. So what will happen at the end is that these fellows are useless. These vertical fellows add up BL1V, BL2V, BL3V, BL4V. Finally, BV, L1 plus L2 plus L3 plus L4, or DL1 plus DL2 plus DL3 and so on. Integral DL, technically speaking. And that happens to be this diameter, twice R. So it shouldn't matter. Shouldn't matter. This or that. But you should be able to explain that. We discussed this. Any clarification? Let me know. Now one important point here. RAB is 0. In fact, it was important to say it earlier, because otherwise answer will be different. The answer will be beta provided RAB is 0. Otherwise, what will happen is that while the induced EMF is B times length AB into V, induced EMF is going to be the same in all cases, but current can change because you have a straight wire and you have a curved wire. Curved wire has a longer length, so it may have a greater resistance if other things are same. So if you take a curved wire and you take a straight wire, then while the EMF is same in both cases, in case of curved wire, current may be lower. Current may be lower because resistance may be higher. So RAB equal to 0 is quite important to say. Because question talks about induced current. It doesn't talk about induced EMF. Induced EMF answer won't change. whether there is resistance 0 or same, different, whatever. That won't change. If the speed is same, other things are same. This is the closed loop. And clearly, as the wire slides down, the area of this fellow changes. So while B is same, angle between area vector and B is also same, the magnitude of area vector is changing. And due to that, there will be induced EMF. However, you can also do this problem by motional EMF approach without bothering about loop and Faraday's law. Only look at this wire and look at its speed and apply BLV formula. V is perpendicular to length, but it is not perpendicular to B. Break V into two components. This is the horizontal surface. This is the inclined surface. B is vertical. V is along the incline. One component of V, that is horizontal, parallel to this. If this is theta, V is parallel to incline. So if this incline is making theta with horizontal, then V is also making angle theta with the horizontal. V is on the plane, right? If plane is making angle theta with the horizontal, then any vector lying on the plane will make angle theta with the horizontal. So horizontal component will be V cos theta. You can think of vector V like this. That will be easy. Think of vector V like this. And V sin theta will be down. If you have any problem with components, let me know. If it is okay, then the vertical component of V and this B, they are in the same line. No use talking about this component. That component cannot create shift along this length. But this component of V will be able to create shift. Electrons will accumulate on one side due to that, and we will have some EMF induced across the length, and that EMF will be BL V cos theta. BL V cos theta. Show that B equal to, all right, constant speed is the key here. How can speed be constant if something slides down an inclined plane. mg sine theta should accelerate that thing, and the speed should go up and up and up. So the key here is the constancy of speed. Why does it become constant? Because of induced EMF, and more importantly because of the closed loop, there will be a current, induced current, and that current will be such that it will try to oppose what is responsible for flux change. Who is responsible for flux change? The fall. Fall is responsible for it. So current will try to oppose that fall. So imagine a force that will be in opposite sense to mg sine theta. And that force will balance mg sine theta, and that's the only way you can have a fixed speed. So some force or its component must be acting against mg sine theta, right? So we would be interested in magnetic force. We would be interested in magnetic force. So we are interested in current. We have found EMF, BVL cos theta is the EMF. Now current will be this EMF divided by resistance. Resistance is how much? This is R. Smooth, thick pair of metallic rail. Alright, thick pair means neglect resistance. Thick wire has negligible resistance. So the total resistance will be R only then. So current will be BVL cos theta divided by R. And magnetic force will be how much? Only that wire is moving. So IL cross B formula. IL cross B formula. Can you tell me what is the angle between the length and B? Length vector and B vector? I want to apply IL cross B formula. Current is flowing here. B is up. On this current, B will apply force. So IL cross B formula has to be applied. So can you tell me what is the angle between the length vector and the field vector?
Sir, theta.
Theta.
So 90 degrees.
90 degrees.
$90 degrees. 90 degrees. It's like this. This is the incline. On this, imagine a horizontal line. And keep your finger up. That's magnetic field up towards the roof. So this is the incline. Horizontal line on this incline. Magnetic field is up. What is the angle between the horizontal line and magnetic field? That's the question. Horizontal line along the incline. This one. And this. That is clearly 90 degrees. The question is not what is the angle between the incline and magnetic field. Question between, angle between incline and magnetic field is a different thing. Some horizontal line on that incline and magnetic field. That's the angle we want. That angle will be 90 degrees. Any problem with that? Let me know. So magnetic force will be that current multiplied by the length L multiplied by V, BLV, or rather ILV. So that I, that length AB into B, sine 90 is 1. That's the total magnetic force acting on AB. Okay. Now let's find out the direction of the current. Will it be as shown there or will it be different? Let me see. Will electrons come to the right side if V is downwards? Can you check that? Actually, this is the important V, this V. Use this V and this B and see if electrons will deposit here or not. It is correct. Electrons will deposit here. Positive will come here. So you got a battery here with positive terminal here. So current will flow like this. Use this V for V cross B formula and you will find positive charge will come here, negative charge will go there. So current will be like that, B to A. Now current is going from B to A. Magnetic field is up. What do you think will be the direction of force on BA wire? Direction of force.
Same direction opposite to V cos theta.
Opposite to V cos theta.
Yes, sir. So
You mean it will be parallel to the ground?
So towards the viewer.
V cos theta, when you say towards the viewer. I haven't used that convention here towards the viewer or away from the viewer. The way I have done the drawing, it's done differently.
Negative of ZX is.
I have not even defined Z-axis here yet.
Along B.
Just tell me one thing.
Cos theta.
Will it be parallel to horizontal? Will it be parallel to horizontal, parallel to the incline, or towards the sky, vertical? Three answers, three options I am giving you. Parallel to the horizontal, along the incline,
So parallel to
the
horizontal.
horizontal. If it is parallel to the horizontal, will it be towards V cos theta, left, that is somewhat left in this drawing, or will it be opposite to V cos theta?
In the direction of V cos theta.
V cos theta.
If current is from B to A, and you have to use IL cross B formula, then it should be opposite to V cos theta. This is your length vector. This is your B vector up towards the sky. If you have a problem in visualizing, you can always do it like this. Take this as your x-axis, this line. This is y. Now this is y. And up as z. X, y, z. So V cos theta is minus y. AB is parallel to x, but the current is from B to A. That will be minus x. You have to apply IL cross B formula. Length vector is along BA. That is minus I cap cross B. B is along K. Minus I cross K. What is that? Isn't it J?
Yes, sir.
Yes, sir.
And J means Y. This is Y. This is Y. This is also Y. This is minus Y. Are you able to visualize this?
Yes, sir.
Magnetic force will be parallel to the horizontal. Parallel to the horizontal. And it will be this much. And speed is constant. That means mg sine theta is balanced. Now the question is, if magnetic force is parallel to the ground, who will balance mg sine theta, which is along the incline? Any answer to that? This is mg sine theta here. Mg sine theta is along the incline. But FB is not along the incline. FB is parallel to horizontal. Who will balance this mg sine theta? Any answer? What component of FB will balance mg sine theta?
So cos component?
The cos component.
Cos component. It's easy to visualize here. FB is basically parallel to this. This. FB's component along the incline will be FB cos theta. And that's exactly where you have mg sine theta. FB cos theta will be, if this is FB vector, if this is FB vector, then this is FB cos theta vector. FB sin theta vector will be, you're not interested. FB sin theta component will fight with normal reaction basically. FB sin theta, mg cos theta, and normal reaction. They will fight with each other. We are not interested in that. So FB cos theta equal to mg sin theta is what you have to do now. Just do it. FB cos theta equal to mg sin theta. Just do that. Put suitable things and see if you are able to get B equal to this or not. This is a very conceptual question. So many components we have taken. Any question if you have, just let me know and I will explain that part. So are you getting that answer or not? If anybody
Yes, sir.
confirm quickly and we proceed further. All right. Now this one, goes like this. You can see those sliders P1, Q1 and P2, Q2. You can see that 19 ohm on the right side and these two sliders are 2 ohms each. So 19 ohm, 2 ohm, 2 ohm. The rails are at the top and at the bottom. Speed 5 centimeter per second written here for both. That's the speed, not velocity, for both. Magnetic field is cross, it's there everywhere, and it is 1 Tesla. First part, if they are both going towards right side, if they both go towards right side, both arrows to the right side, what is the current in 19 ohm resistor? If both are going towards the right side, let me delete minus plus. Okay. What is the current in 19 ohm resistor? Yes, anybody? V same, B same, length is same for P1 Q1 also and P2 Q2 also. So shouldn't they generate identical batteries with identical times? Yes? Or no? Obviously yes. And which side is positive is not really important to answer how much will be current. Suppose this is positive. We can give that answer also, which is positive, but suppose this is positive, this will also be positive. So it's like two batteries in parallel basically. Two batteries in parallel. If this is plus, this is plus, plus minus, plus minus. Same BLV for both. So how will it increase the current? Two batteries in parallel doesn't mean current is doubled, or does it mean it is double? Okay, just a moment. Internal resistance I will have to check. If batteries have internal resistance, okay, 2 ohm is given. Alright, then it becomes little interesting. 2 ohm are there. So put some EMF here along with internal resistance, put some EMF along with internal resistance. And then use that formula that we have discussed in current electricity. Two batteries in parallel equal to one battery. You remember that? One battery E comma R, other battery E comma R. Then the equivalent battery is E comma R by 2. So, okay, it's written here, E comma R by 2. So replace both by single with E. In place of 2 ohm, it will be R by 2, 2 by 2, 1. So E 1 ohm and 19 will be in series to 1, so 19 plus 1 equal to 20. Current will be E by 20, and E will be how much? BLV. B 1, L 4 centimeters, V 5 centimeter per second. Divide that by 20. And see if you are getting 0.1 milliampere as the answer or not. If you don't get it, let me know. Are you getting it or not?
Yes, sir.
Now suppose the left fellow is going to the left, and the right fellow is going to the right. Then what will be the current through 19 ohm resistor? Well, clearly the two batteries will be now plus minus, minus plus type. Supposing right side is like this, left side will be like this. The equivalent circuit, electric circuit, I have drawn below. You can see that. Now it becomes an electric circuit problem. If this is I1, if this is I1 and if this is I2, current here will be I1 plus I2. You will have to find out I1 plus I2. And that you should be able to do. Answer is 0. Any questions? We stop at this point.